Welcome back.
Hi team, sorry for the delay in this video and for being a bit out of it in terms of communication, but 2 out of our 3 team members have been sick with COVID. Woo! We're finally back and healthy and in person together. My name is Elizabeth.
My name is Ohm.
And I'm Liam.
We are Mrs. Deal, Team 6. A reminder of our project, it is going to be a device that deals cards out to a user-specified number of players, and that includes burning cards and the 5 cards for the river, the flop, and the turn. How this will work is a camera is going to be placed underneath the deck of cards as it's dealt. It'll recognize each card that is dealt in real time and combine that with information about our motor's location and game rules to know where each card is dealt and to whom. So it'll be able to recognize that the Ace of Hearts was dealt to player 5, the 9 of Spades was the card that just got burnt, and the 2 of Diamonds was the first card of the flop. And while this is all happening, we're going to be displaying each player's hand in real time on our live website, as well as the 5 cards for the river, the turn, and the flop. So some goals in terms of our camera tracking and website display, some more specifics are we are using template matching to accurately identify the cards' identities. And so we want it to be accurate and robust enough that it would be able to do this in real world conditions. Because right now we're using some pre-taken photographs. And so we need to actually use more likely lighting and distance from our camera with our ESP32. And then our goal is that it'll update our server with that information. And as I was saying, the image input needs to come from the quality that is at the level of our ESP32 camera instead of just hard coded, which is what we've been working with for practice in order to make sure that we have a proper method that actually works.
So the Python program right now uses template matching and OpenCV. It can accurately identify the card and display the number and suit of the card in the serial monitor.
Additionally, before we have integrated these 2 parts of our design, we've been working through different examples of some server functionality to see how they work and just different things that we are going to want to integrate into our final project design. So some examples that we have been practicing with have been displaying saved images on our server or a live camera feed from our ESP32. We can also take pictures and display them on our server with our ESP32 camera. We have a server example where we can interact with a physical push button to turn on an LED, and that corresponds with the on-screen button. And we have another one that asks for user input. So for example, it would ask how many players are playing, and the user can input that number and then store that data. But as of where we are at right now with our delay from Liam and I being sick with COVID, we have not successfully been able to integrate all of these into one with the Python code for the template matching, but that is obviously what we'll be working on shortly.
This is a demo of the updated recognition software. And so essentially, ReadCard is the name of the Python program. And here I've manually inputted qd.jpg, which means that it's an image of the Queen of Diamonds, QH is Queen of Hearts, 9H is 9 of Hearts, 9S is 9 of Spades. And you see the program outputs accurately identifies the cards. And over here are 2 examples of 2 similar looking cards. A heart and a spade are kind of similar, and they're both number 9. This template matching does not utilize color, and so it's mostly based on the shape of the card. And it shows here that it's able to identify them accurately. One of the design changes we made was eliminating the card flipping arm for the flop, turn, and river. Privacy will still be maintained since the cards will be dealt face down. So it's not like we're going to have issues of people seeing what cards are being dealt, etc. This also reduces the mechanical complications of the project. And we need a little bit more time to focus on the software side and integrating what we have going on so far. A little bit more of the thought process behind this change is going to be explained when we discuss what we learned in our interview.
So as we were talking to another avid poker player, we were discussing the possibility of flipping the dispenser itself in order to deal the cards face up for the flop, the turn, and the river. This was an idea mentioned to us by Ilya that could be helpful in simplifying how we do it. However, we found that general extra manipulation of the deck and the order in which the deck is dealt out is an extremely taboo thing for poker. Poker players tend to be, I guess, a lot more superstitious, but they'd prefer to manually flip the cards over from the flop, the turn, and the river, rather than have the deck do it for them. Thus, we decided to eliminate the flip arm in the first place.
So one thing that I have been learning about is working with the different types of servers I mentioned. And here is just a fun example that I did to practice displaying an image. And I used a beautiful image of my old man, Buddy Boy. And I wanted to make sure we could do this because one of our plans for the design is that it'll display just sort of generic card images for each player's hand at the end of, once we've identified their values, we'll display them for each player. So I wanted to make sure I could do that. And so here's a cute example of that process.
Here we have our bill of materials and Gantt chart as well. We had a couple extra motors, the Parallax High Speed Continuous that we added in, as well as our battery holders and batteries for our outside power source. And our Gantt chart as well, we're a little bit behind on, but we are getting there is the idea. Questions? So firstly, we want to use the SPCam to take an input image for the Python program to identify the card. What we have been having most trouble with is integrating the card recognition software with our website itself. So if anyone had any specific ideas or suggestions or any links that could help us integrate them, that would be extremely helpful. The other part that we're having an issue with is that our continuous rotation servo motor won't give us a variable speed or variable direction when we hook it up to an outside power source, regardless of whether or not it matches one from the ESP32 itself. Why? I don't understand why this is happening. But we also need a higher power source as opposed to the 3.3 volts or even the 5 volts if we want a stronger motor. So having the suggested 7.3 volts for a continuous servo motor would be helpful if we could figure out how to still control speed and direction. Make sure to like and subscribe.
Thanks, guys.
Thank you.
Woo.